Good morning, everyone. We're going to get started here in a minute. My name is Steve Kinney. I'm Director of Training for Smart Vision Lights. As we do the webinar today, we're going to talk through the webinar. We can see your questions in chat, so if you do have a question, please enter it in chat, and time permitting, we will answer some questions at the end, and anything we don't get to in the webinar, we'll respond to you afterwards. With that, I'm going to get started this morning, and today we're going to talk about the right light, selecting machine vision lighting like a pro. So as you can see from this slide, this is just a small sampling of the offerings we have here at Smart Vision Lights. And you know, this is typical too, not just of Smart Vision Lights, but of other lighting companies and machine vision. And that's because when we have machine vision applications, we need to get everything just right to get it lit and get the best image into our machine vision system to get the best possible outcome. And to do that on the complex variety of shapes and objects and finishes on those objects that we see in machine vision, it takes very specialized lights in some cases. So what you see here is a piece of our product line and pointing out that we have a whole bunch of sizes, shapes, diffused, non-diffused, all these kind of variants in our lighting, and that there's a purpose in each one of these lights. Sometimes they overlap, you have choices, but in general, each one of these lights does have a purpose that's out there and something it needs to do well for you. However, to simplify it, we're going to reduce it down to 6 of the most common form factors. Though we have all these lights, not all of them are used equally, and we need them all for certain cases, but 80-20 rule, a small handful of these lights are used in more than 80% of the time. So the 6 common form factors we're going to examine today are bar lights, often called linear lights, ring lights, backlights, dome lights, front lights, and spotlights. So we're going to look at why these are the most common, why they're popular, and when do they work best. What is each one good for you? So before we dig into the individual aspects of the lights, we want to introduce what's probably the most common effect in lighting for machine vision, and that's bright field versus dark field imaging. This is something we teach from the very basics on, and people often, when you hear this the first time, often go, dark field imaging. What is dark field? That just sounds like an oxymoron, dark field for lighting. But there actually is a purpose, and we can use it to our advantage. You can see from the diagram here that in lighting, sometimes you hear us talking about the lighting W. We made this W by starting from the lens and tracing a red line from the center line of the lens to the outside of our field of view, wherever that may be, and then doing the same mirrored around the optical axis on the other side. Once we have then the point of contact beside the object in the field of view, then we're going to mirror that line through another invisible vertical axis and point it out in space to create the outside of our W. This is called the lighting W, and as your working distance increases or decreases, or your field of view increases or decreases, the W is going to get fatter or more narrow. But basically, this sets up the boundary for our rule of what is bright field and what is dark field imaging. If it's inside the W, filling from the top down, then it is going to be what we call bright field imaging. If it's outside the W, filling from low angles and from the outside in, it's going to be what we call dark field imaging. And these two effects are inverse of each other, and as we'll see in an example here, they give us a different effect for inspecting different aspects on our objects. So depending on what the inspection and task at hand is, then it will lead us to want to start with bright field or dark field imaging. So as I was saying, what happens here is bright field, the light comes from above and reflects into the camera. So if we look at the bright field diagram on the left, then what you can see is from the light on the far right of that diagram, when the photons leave that light and strike the flat surface down in that little recess, there's an angle that's equal and opposite where the light hits, bounces off that flat surface and into the camera. This causes that surface to reflect a lot of photons and become bright. Conversely, when we look at the light on the left, primary light coming from that primary angle strikes that bevel in the object and bounces to the outside away from the camera. That then reduces the number of photons making it back to the camera because there's no angle to come directly from the light source into the camera, and it bounces those photons into space and they're not registered, thus creating a dark spot in the image. So now, let's start with, I'm going to talk about these two choices together, but let's start with the two most common form factors, which are bar lights and ring lights. And as you can see from this slide, these are again just a few examples of the products which are available to you. But you can see on the left we have our linear lights or our bar lights, and on the right we have various of our ring lights. And each of these within its category has a little bit of purpose and a little bit of different geometry in the light. But you can see that we have varieties to get the right light, the right size into the right application when you're choosing these. So notice on the linear lights we have from the mini linees all the way down from a LM45, less than 2-inch light, all the way up to standard 300 millimeter or 12-inch linear bar lights, which tends to be the standard length in a linear light or standard increment. Often they're 300, 600, 900, and so forth. Both of these form factors are extremely popular, but they're a little bit different as well. So why are these two the most popular? Well, they're easy to set up and use. The ring light just simply, as the name describes, fits around the lens in a ring and usually mounts to or very near the camera, and if the camera's mobile, will tend to move up and down with the camera. The linear lights then are often used, if it's a simple application, you might use one. Most often linear lights are used in pairs where we put one on the left and one on the right and angle them in to make equal and opposite fields. So cancel any shading from one being closer to one edge than the other. So the linear lights can make a little bit broader area perfectly uniform and give us some more adjustability on that uniformity. But this comes with some adjustment. So they're easy to set up and use, easy to mount. There's lots of diffusion, filter, and lens options because they have a fixed emitting surface and it's relatively controlled. It's easy to make filters and so forth that fit, especially in the linear lights. And they're both very easy to mount and have adjustable mounts as well. So if you look at this diagram, this is showing us a bright field diagram of the two form factors now. And you'll notice that we're showing kind of the working range for these lights. So if you look on our websites, we always state a working range online for the lights. And what they're basically showing you is how you can adjust light within the working range. As I was saying on the ring light diagram, you can see basically the ring light is just going to move in and out in a linear fashion, usually around perpendicular to the object of interest and along the optical axis. Sometimes they can be offset a little bit, but the primary motion is to move this in the Z optical axis closer and farther. As you do, the spot of light around the object you're illuminating gets bigger and smaller. In some cases, we have lens choices, so we can make the cone angle from the ring light steeper or wider angle, but for whatever lensing is in the light, you get more field of view as I raise the light and less as I lower it. When you look at the diagram with the linear lights, then you can see what I was saying about the adjustability. Now you see with the linear light, we're showing a pair, and you would tend to get a bright edge on whichever side the light is because it's shortest path to the light from that edge when it's not perfectly over center. So we get a little bit of a keystone gradient where it's bright on one edge and dimmer on the far edge. But when we put two linear lights crossed, as you see in this manner, then those gradients can be adjusted and basically nullify each other to make a very uniform square field in between the two linear lights. And as I was saying about adjustability, the linear lights, notice we can move them up and down in the z-axis, which will tend to get us more and less field of view, but they also tilt in and out around their horizontal axis to focus them in and out. And as we were saying, bright field and dark field, you know, we need to control that angle. It needs to be steeper when it's a bright field imaging situation and shallower and wider when it's a dark field situation. So the tilt adjustability besides the height gives us the ability to control both the working distance from the light to the object and the angle the light is coming at that working distance. You can also move them horizontally in and out to get more horizontal working distance. If I need to position them at a specific angle to the object but need to get further away, then we simply grab and pull that vertical stanchion back further horizontally. So the ring light is actually the easiest to use because you're probably going to mount it to the camera or around the camera and just start imaging with it with the camera. And for a lot of things, that's all you're going to have to do is get it right, get your field of view right, and choose the right kind of ring light for the object you're inspecting. But you do have limited adjustability. The linear lights, also good choices, and often in machine vision, we can't look down that vertical axis. If we're over a conveyor belt or something, we need to, and there's automation moving in that area. Sometimes we can't put cameras directly over center. And the linear lights are better for getting off to the side, especially if we have a side-mounted camera as well. And they offer then more adjustability than the ring light as far as getting your overall height, your angle to the object, and your light working distance between the end of the light and the object correct. So this example is showing you a small electric fan used for cooling in like a CPU or something. And it's got a bright shiny label and it's black on black plastic. So it's a little bit tricky imaging. And what we're showing you is we can achieve a good image with both of these setups in the bright field. So if your task on hand was to do something like this, then the ring light might work easiest, and you're going to mount it on the camera as shown in the top part of the image there, and just set it up, get it right, and move on. You're going to do similar with the bar lights, but again, you have a little more adjustability. If you're getting a particular glare, or those fan blades were on a particular angle or had a flat in an area that was catching your light when it came around, the bar lights might actually offer you a little more adjustability to correct those kind of problems. But you're probably going to choose that only if you have a problem to correct. Or again, you might not be able to work in the center of your area. Either of these, though, you can see can create a very good image, and the fan itself, that bright label is silver and somewhat glossy. The plastic, though it's black, has some texture and some gloss to it as well. Both of these need controlled lighting, either a bar light or a ring light, to get a very good flat image. If we just use the ambient lighting or light that's around in the room, there would be angles between that light and the camera which captured glare, and parts of the image might not be as good even if it generally were working. And more than that, you'd be subject to changes in that room lighting. In machine vision, we always want controlled lighting in our space for imaging, and having the right geometry of light, as we're talking about, is one of those. And anything that comes from the outside of that controlled geometry is then light pollution and can only hurt us, not help us. So with bright field, both of these are viable options on this kind of object. But let's talk about dark field now. Now if we change the discussion and start talking about dark field but using ring lights and bar lights. Well, you can see in the diagram that we have basically the same adjustments, but you can see now the linear lights on the left are moving up and down, but they're placed at a much steeper angle. Again, they have to stay outside of that W area. It's important to note that outside usually means low and further back, but sometimes again we have things obstructing our view, so dark field can still be higher and further back, but it needs to stay outside the W. So it can still come up from a higher angle and get similar effects, but it needs to be wide and outside the W. So the ring light, you would say, well, I almost can't do that, but the particular ring light we're proposing here is called an RM140. There's also a smaller size, a 75 millimeter RM75. This ring light has a blended surface which emits at varying angles. So near the center of the ring, it's emitting very perpendicular and near the optical axis. As it moves towards the outside of the ring, the angle is getting steeper and steeper till it's near 90 degrees at the opening of the light or the edge of the light. So what happens is as that light moves up and down, that ring light, you're getting dark field effects when it's very close and less, more of a bright field effect as it gets further away, and a combination effect in between. So for dark field imaging, we're still going to use it in the same way, moving in the vertical z-axis, but we're going to get a dark field effect with this kind of a ring light, we're going to have to keep it low and keep our working distances low. You might pull it back enough to get a combination. Sometimes we want a little bright field and start seeing that surface, but in general, you're going to keep it low. The bar lights then are able to be positioned low and to the outside, but again, it's really useful to be able to tilt them because, again, we want to find that right angle where the rock skips off the pond, if you will, or the photons off the surface of the object we're inspecting. And by tipping it in and out, you can get them exactly right and get them balanced as well. So, why is this now important? Well, now we have a slightly different object, and we have the same two setups with the ring light and the linear light we had before, but we have an object, and this object is a gear with splines, and in the middle the splines are actually raised and at an angle 35 to 45 degree type angle. And they're a little bit shiny as well. So look what happens. I can create dark field imaging with a pair of linear lights, but because my surface is specular and those splines want to capture the directional light, then what you see is I start getting a dark field image from the linear lights at the right angle, but I can see the reflection from that angle. So when you look at the image, you can almost see four quadrants. There's two dark field quadrants where the lights are coming from the sides, and at 6 and 12 o'clock, it's actually a bright field image because you're not getting light at the right angle at that tangent, and you're just getting scattered light in there, and you're losing the dark field effect in between. So this is a case where the object dictates what is right between these two form factors. So for a circular object like this with surface details that we need to capture in a dark field setting, the linear lights work okay and you might get by with it, but it's not great. If I were going to continue in a linear light setup with that kind of scenario, I would probably actually use 4 linear lights at 90 degrees to make a perfect square or rectangle around the object. At least then we're getting equal reflection, 360 around the object, and we could probably get a pretty good dark field image in that case. But the thing I'm going to tell you is, well, why bother? Because with the ring light, we'll just put it on there, get it down to the dark field angles and image that. So choosing the right light can also save you a lot of time in a case like this. So now let's summarize our bar and ring lights. Pros for the bar lights include the fact that they're more adjustable. We can control the working distance to the object and primary angle to the object, and a tilt angle to the object. So between changing the primary up and down, tilting along that axis, and moving in and out along that axis to vary our light working distance, we have a lot of adjustability. They're also strong because we can use them in even pairs or 4 of them to make even and opposite light gradients and create a very uniform lighted area in the middle of the bar lights. You also heard me mention they're easy to move around automation and come in from the sides and not directly down the optical axis when we have things moving, such as over a conveyor belt. The cons then are just almost the opposite of those strengths. They're highly adjustable, but they need to be mounted and properly adjusted into the application. You tend to buy 2 or 4 bar lights as opposed to a single ring light. And because of that adjustability, they can also be knocked out of alignment easier. Something can hit one and not the other and mess up the image without making it clear that it's totally a bad image. So the adjustability that gives us some flexibility in getting it right for the application adds some complexity in a linear light. When we look at the ring light and bright field, then the pros are simple. You just get the light, you mount it either to the camera or to supporting it around the optical axis of the camera. You get your working distance right and make sure you have the area evenly illuminated for the right working distance, and you're done. It's usually a one-stop solution. We don't usually use ring lights in pairs and things like that, so it's maybe the most cost-effective and easiest solution. The con to the ring light is then just the same thing. It's an easy one-stop solution, but if I need adjustability, I need to work on those angles from the ring light to the camera without changing my working distance. We can't do those kind of things. Additionally, it should be noted that when using a ring light, almost always we want the ring light to be, the diameter of the ring light to be equal or greater than the field of view of the camera. We can make some exceptions and use wide angle lensing and get things a little better, but in general, the ring light needs to be as big as the field of view. So for larger objects, a ring light can be a little bit of a hindrance, and bar lights start making sense over a very large panel or ring light. Next up, we're going to talk about spotlights. And spotlights are, again, a very simple form factor. They're probably the next most common form factor. And spotlights provide a simple answer for general lighting needs. So a spotlight is just what it sounds like. Think of it as an actor on a stage and a stage spotlight here. Spotlights provide light from a single direction, a single LED source, and with lensing. We can affect the angle. Again, we can put a 10-degree narrow lens in there, 30 medium angle, or a 50-degree wide angle lens in there. The spotlight then lets us point from anywhere. It can be along the optical axis, but it can also be from the sides or the angle. Again, it's very directional. Think of it as a stage light, just like a stage light strikes an actor on stage. It makes a very strong light from a direction and casts a shadow. So do spotlights. In some cases, that can help you, but in other cases, you may have to compensate for shadows and add more spotlights or other type of lighting from the sides to fill in shadows. The real benefit of a spotlight is it mounts where area lights can't or don't fit. So again, we talked about using bar lights if we can't be directly over a conveyor or something like that. Well, spotlights give us another common geometry that we can angle in from the sides, but they are illuminating a more direct, small area. So usually you're going to use a linear light where you can, but if, again, I'm in the middle of a lot of automation, don't have a lot of room for linear lights and stuff, I might put smaller spotlights in areas where I can get them and point them into the area of interest to use it. You can see this in the diagram on the left. You can see the spotlight pointing around, and I can light anywhere in that area. And again, we can use these where other lights just don't fit. It's also notable that on things like the spotlight, we have the same SXA30 spotlights as the fixed ones I talked about where you order it with lensing, but with the A is adjustable, and SXA30 then has a zoom lens that goes from 1/2x to 5x in its spot size, and so you can mount this, and just like you see in the diagram, by screwing the lens in and out, we can get a bigger and smaller spot. Again, think of the actor on the stage and zooming the spotlight in or out to cover the whole stage or just the actor. So this allows us to adjust the spot size to fit working distance and area. It also gives us a very high efficiency because the spotlight, again, is very direct. And so 90-something% of the photons are within that spot area. And by focusing the spot, we can be sure that we're putting our light energy exactly where we need it for imaging and not losing stuff to the surrounding outside. Spotlights can be very efficient for this. You heard me allude to that a single spotlight can be limiting, cause shadows and other things. In simple applications, maybe we only need one light source again. But in cases where you're getting uneven lighting gradients, having problems with shadows, just again need to get light around an area, but you have limited points of access, you can see in the middle and right-hand diagrams that we've added here, cases to use 2 or 4 spotlights and bring them and join the spots together in the middle to illuminate bigger areas from multiple points. Spotlights are really good for this. And a spotlight, again, is a low-cost form factor. So spotlights typically have little or no diffusion. We do have versions and can add more diffusion for you to make them less harsh and a softer, more diffused light. But by the nature of a spotlight, we're projecting it from a single source into an area. If we add a lot of diffusion, the intensity falls very rapidly. So spotlights typically have little or no diffusion, and you're going to then aim them at targets that are less glossy, less shiny, or less specular. The directional light itself can be good or bad depending on the application. Again, sometimes the shadows hurt us a little bit and we have to do things from other angles to even it out. But in other applications where we're trying to catch height profiles or even do some quasi-dark field imaging, maybe that directional light's actually helping us catch or highlight edges. So the directionality can be a good or a bad thing depending on if I want to highlight edges or if I'm having problems with glare. So the spot lights are very good all around. You just have to think about, can they give me the right result in my application? So in summary for the spotlights, the obvious pro, again, is the simplest form factor. I mount it once with one mounting point. It's a low cost form factor as well. Easy to mount and place in tight spaces. We can project through obscured areas that must remain clear for automation, and it's a strong and brilliant light. We get a lot of light out of a small spotlight. The cons then are that strong and directional light can cause glare on specular or bright surfaces. Moving on to the next form factor, we're going to talk about dome lights. And you can see from the diagram here on the right that a dome light is just what it sounds. It's a dome, a half dome, if you will, with a hole in the middle for the camera to project through, and they're lit from the outside ring of that dome. So there's actually a ring light facing upside down in there, so it's facing upwards in the dome. So all the light that comes out of the dome and onto your object has been reflected off that curved surface, which is also coated white with optical matting, as you can see inside there. And you get what we often call a cloudy day lighting effect. That means light is highly diffused. There's light for any point in the lighted area. There's light coming from all directions, 360, and all angles from the sky above it, which tends to reduce glare and give very even lighting. So these lights then are very good for specular, shiny, or glossy surfaces. So things I just talked about not working so well with the ring or linear lights or the spotlights, you typically do with a dome light to get that down. Now the dome light will make the surface appear flatter and reduce surface detail and height detail. So again, think if those things are helping you or whether you just need a nice flat image, and make your choices according to that. They are a larger geometry with a fixed field of view and working distance. So again, ease of use, a dome light is pretty good because you can't use them far away. The light is diffused, it's coming out that fixed aperture, and it doesn't project very far. So usually the dome light is down within a few inches of your object, and your object is within that inscribed area. In particular, smart vision dome lights then, as you can see from the image, are inside a metal housing with T-slots on all sides. There's 16 T-slots around most of our lights for mounting, so you can grab them firmly from one side, grab them from opposite sides to reduce vibration, and in all cases they're enclosed in metal to be strike resistant. Dome lights are typically either thin metal or fiberglass shells for the dome itself, and they're notoriously fragile. Most manufacturers don't enclose them like we do, and they often get knocked, cracked, chunks knocked out of them or other things because they're not the strongest form factors on the dome itself. So dome lights then solve issues with glare and illuminate otherwise difficult samples. We can see how the DDL250 dome light solves the glare caused by the spotlights in the previous example. So when we look at this now, you can see on the object, again, that there's no glare and that we have a flat uniform image, but unlike the spotlight, you'll notice that the height variations are then muted in this case. Okay, next up we want to talk about DLP or diffuse light panels, otherwise known as panel lights. These are kind of like what a lot of you may know as a backlight, but a DLP or a panel light is meant to project light forward. So a DLP starts acting like a large ring light, and you heard me talk about the ring light needing to cover the whole area or field of view. So when the ring lights get too large and we need to cover a large field of views and still want a very direct lighting effect, we tend to use the panel lights to create bigger and bigger areas instead of trying to create humongous ring lights over the area. And that's because not only does the light have to be big in terms of the width or the diameter, but unlike a ring light, as we cover those big areas, we have to fill the light back into the middle. So a super big ring light wouldn't be as even uniform illumination in the middle of the lighting area. So this is where we start using DLP or panel lights. Sometimes they're called flat domes, and they have similar benefits. So just like we were talking about with the dome light, I get highly diffuse lighting from all angles in the sky, and there's photons coming at all angles off the surface. Then this creates a nice diffuse lighting, which we use for larger areas, shiny or difficult items. And again, the big benefit over either dome or ring lights of a light panel is we can just make these in bigger geometries and they remain thin and take up less total volumetric space. So you're probably not going to move to a panel light. They can be a little more expensive because this is what we call a backlit panel light, meaning there's LEDs at a high density, all perpendicular to the surface. So these lights are higher power and have a lot of LEDs, which make them a little bit higher cost. So you're not going to use them where a ring or a bar light does work for bright field. But when you have to cover large areas, then they're more cost effective than trying to use multiple lights. So the DLP and panel lights then help you fill the sky to be effective with larger specular items. And then, as I just alluded to, the opposite of a panel light is a backlight. This is the same thing kind of as the panel light, but the light is coming from the rear of the objects. And to the camera, things are going to start coming black and white, just like looking at a person walking at you with the sun going down behind them in their back. You see the black silhouette of the person. That's what panel lights are generally used for. So backlights provide illumination from behind an object to provide a silhouette. Heavy diffusion is critical to provide a uniform background to the camera. We don't want any bright spots. We don't want the camera seeing bright around each LED that it's looking up in. So we have to heavily diffuse it to get the background to be evenly and uniformly lit. This is a unique geometry that is very useful in applications such as optical gauging and metrology. So again, if I want to put something down in optical gauging, I'm checking my parts. It might be as simple as a washer that I need to gauge the inner and outer diameter, looking at the ovality, splines on a gear, things like that. Those are typically done with optical gauges, And if we're going to do it in a machine vision system, we're going to use a backlight, put the object down there, look at it perfectly perpendicular with the camera, and get an even silhouette with no edge effects that is easy to gauge. So there's three places then where we typically use backlights. One is gauging and metrology, as I've been alluding to. The other is simply finding outlines. So sometimes we need to outline a product. They're used often for checking gaskets, for example, that there's no flash in the gaskets, that the operator's selecting the right gasket, the right assembly step. In those cases, they're just outlining gaskets or sometimes the outline of a part to verify that they have the right parts. And then in the cases of SWIR lighting, we use backlight sometimes to project SWIR light through an object. So you can see in this example, we can see through the polyethylene container and see the object in the center. So backlights are often good for this, especially if we're using SWIR or non-visible lighting, then this is a way to get see-through objects with the SWIR and get the outline we need of what's inside. Now there is a special backlight case I do want to mention before we wrap up here. The mini backlights are not only smaller, they're very high performance, and they have a film in them for gauging to collimate the light and make them very good for gauging and all the things we talked about in the previous slide. However, what people don't think about is these kind of mini backlights are becoming very common now in camera calibration. All of our electronic devices, our cell phones, our PDAs, our computers, and a myriad of other devices all have cameras built into them. Those cameras are small pixel cameras, very tight, but yet we expect very high performance. We want the performance of our digital SLR out of them, yet they have to fit inside our cell phone. And to get the magic that they get out of them, Samsung and Apple and the other vendors, they have to calibrate these to a very high level to make the imager that would otherwise be kind of poor perform really well. And they do that by calibrating them and characterizing them. So to do this ideally in a lab setting, we would use what's called an integration sphere. It's kind of like a full 360 of the dome light we had there. It's a full sphere, which is a hole for the camera and some photodiodes for precision measuring inside. But photospectrometers cost a lot of money and don't survive well on the line. They're again fragile because they're typically fiberglass shells. They're $20,000 and $30,000. So to get around this, camera manufacturers of electronics with cameras in them have started using these flat panels, asking for very high calibrations. We can customize them, and using them like they're an integrating sphere. Now the reason I mention it here is we do have to take, unlike when we want to do gauging where we want the light to be very perpendicular to surface, we do have to remove the collimating films. In this case, the light comes off at all angles so that when the camera is looking into one of these mini backlights at very close range, it sees it as infinite, as if it's looking into an integrating sphere. So we just want to mention that if you get in an application, recognize, number one, if you need to calibrate cameras or you're doing other electronics assembly and need to calibrate imaging devices, that these kind of panels are very high performance and used for that. But also recognize you should be talking to Smart Vision Lights or technical people or applications engineers and letting us help you get the light configured properly for those applications. So the mini backlights provide a high performance and compact thin package. They're specifically designed for optical gauging of the small parts and electronics, useful in highly automated assembly where space is tight. Again, these are very, very thin, have very small borders. So unlike the bigger backlights, you're going to use these where there's electronic assembly. Again, to pick on the phones there, your iPhone was never touched by human hands before you took it out of the box, and they're doing all this assembly by automation. these kind of mini backlights get lighting in that area where they can move all their assembly above it, but not be worried about the thickness of the light or the frame around it. They do have, as I alluded to, an optical film for sharpening. So if you look at the two images on the bottom right of this slide, you'll notice with standard backlighting and no optical films, the screw has reflections off its shiny surface. The threads become hard to see due to the reflection off those beveled edges. And when we put edge enhancing film in these, you'll see that the whole outline of the screw gets stronger as we want more contrast. In particular, the threads become sharp and we're able to gauge them accurately. So do be aware of this. Not all backlights are the same, and not all manufacturers of backlights necessarily put all the same effort into collimating films and fine-tuning these for your application. There is a reason that there's a difference in them. So now we just want to summarize real quick. We've talked about 6 geometries that are common. Again, these make up most of the applications, but we do have complete lines. If you have other areas where one of these 6 isn't the right light, do consider the big picture. Just come and talk to the experts at Smart Vision Lights, either any of our technical people or application engineers here. We're easy to get a hold of and offer free advice in your applications. All right, everyone. So I want to thank you all for watching and listening today. I hope everyone got something useful out of this. We're going to wrap up. We had a few questions in the comments, so we're just going to wrap up with a few questions real quick and then be done here. So first question, can I do dark field imaging with a dome light? Well, the answer to that is generally no. We talked about using bar lights and ring lights in either dark field or bright field mode, depending on the positioning of the light. But in the case of a dome light, when we talked about, we showed the diagram and showed how it's kind of a cloudy day illuminator. It's lighting, light is coming from all angles from inside the dome. So there's no way to help that a dome is always shining down in a direct way. Even though there's some side angles of light that could be dark field, there's so much light coming from the middle that the dome is a dedicated bright field light. So some geometries like bar lights and ring lights can be bright field or dark field based on their placement. Other geometries like a dark field ring light may be dedicated dark field, and other ones like a dome light may be dedicated bright field. Next question says, is a backlight always heavily diffused? What if I want less diffusion to make it brighter? Well, by the nature of a backlight, we're always looking or shining that light directly in the camera to create the silhouette or the kinds of things we talked about in those applications. And because of that, the backlight has lights on the backside of the LED that are shining directly in the camera. So kind of by definition, we have to have heavy diffusion on a backlight in order to get it uniform, and so that you don't either directly see the LEDs or just see a bright spot around that LED. So yeah, a backlight, we can put more and less diffusion on a backlight, but a backlight is always heavily diffused. And if you need it brighter, the only way is longer exposures or to use a brighter product that has more power density behind the backlight. There are some limits there. We can't put a clear diffuser and just shine it up in the camera. And then last question here we'll take before we wrap up. Which is brighter, bar lights or ring lights? Well, now that's an interesting question, and I think I know what's at the heart of that, but you have to look at the situation. So most ring lights are dedicated, like we talked in this presentation about the RM140, which is a 140 millimeter ring light, which is 6 inches essentially. So the ring lights use different LEDs than the bar lights typically. The bar, the linear lights use big high power LEDs, plus they have more surface area. So generally the bar light is a larger form factor and will tend to be brighter than the dedicated ring lights like we showed today. However, do remember we make large ring lights, and when you go very large in a ring light, it becomes a panel light with a hole in it, and we have ring and panel lights that are much larger. Those will have more LEDs than the bar light. So is a bar light brighter than a ring light? You have to take it in stride. The way we showed it today, two 300 millimeter bar lights to create a illumination area compared to one RM140, probably the bar lights are brighter in absolute intensity. However, if you're comparing to other geometries, some of the mini bar lights or some of the larger ring lights, that's not necessarily true, and you should evaluate the product data. Also, working distance is a big factor. The ring light tends to be a little closer, and since the light falls off as the square of the distance, a ring light may be brighter just because of the amount of illumination that's making it to the scene, whereas the bar lights tend to be used a little farther back as we showed in our setup. So look at your product data. If nothing else, call us and get some help. We do have application help. People like myself or Chris Morris, our application engineer, would be happy to look at the data and help you make decisions. And if you don't take anything else away from this webinar, I hope you get that. Do contact us if you need any lighting help. We're always here and available as a resource to you. With that, thank you everyone for watching.